Hello everyone, welcome back. I'm Purnima studying in Sri Venkateshwara College of Engineering, Bengaluru from the Department of CSE Data Science. Today in this video we are going to discuss about the data structure and its algorithm. The topics we are going to cover in this video are Introduction to Structure and Union, differences between structure and union, applications of structure and union, introduction to data structures, arrays versus linked list implementation and traversal, stack data structure, its definition and operations, queue data structure, its definition and its operations, comparison of stack and queue, conclusion and summary. Now, introduction to structure and union. Structure is used to group different data types under a single name. It is user-defined data type. The struct keyword is used to define the structure. The items in the structure are called its members and they can be of any valid data type. Union allows storing different data types in the same memory location. We can define a union with many members, but at a given point of a time, only one member can contain a value. Differences between structure and union. There are two differences, that is memory allocation and data access. Each member of a structure has its own memory space and union shares memory among its members. Data access. Structure members can be accessed simultaneously while union allows access to only one member at a time. Now, let us know the applications of structure and union. Structure is used for representing complex data structures like trees, graphs, and records. Union applied in scenarios where different types of data need to share the same memory location. Next is the introduction to data structures. Data structures are crucial for organizing and managing data efficiently. They are the building blocks of software applications, enabling the storage, retrieval, and manipulation of data. The choice of a good data structure makes it possible to perform a variety of critical operations effectively. An efficient data structure also uses minimum memory space and execution time to process the structure. A data structure is not only used for organizing the data, it is also used for processing, retrieving, and the storing data. There are different basic and advanced type of data structures that are used in almost every program or software systems that has been developed. The structure of the data and the synthesis of the algorithm are relative to each other. Data representation must be easy to understand so the developer as well as the user can make an efficient implementation of the operation. Data structure provides an easy way of organizing, managing, and also storing data. The needs of it are data structure modification is very easy. It requires less time, saves storage memory space. Data representation is very easy access to the large database. Now, arrays versus linked list. Arrays store data in contiguous memory locations, making random access faster. They have a fixed size and can be inefficient for insertion and deletion. Linked list use pointers to connect elements, making insertion and deletion more efficient. They don't require contiguous memory and allow dynamic memory allocations. Next is the linked list implementation and traversal. Implementation. Linked lists are implemented using nodes, each containing data and a reference to the next node. Traversal. Traversal involves visiting the each node starting from the head and following to the next pointers. Now, let us know the stacked data structures, definition and operations. LIFO principle. A stack follows the last in, first out principle for data manipulation. Operations are stack operations include push, that is addition, and pop, that is removal of elements. Next is the queue data structures, definition and operations. FIFO principle. In stack data structures, we have used a LIFO principle, and in this queue data structures, we'll use the FIFO principle, that is first in, first out. Queue follows the first in, first out, that is FIFO principle for data manipulation. NQ and DQ, that is these are the key operations of queue data structures. Queue supports NQ, that is addition, and DQ, that is the removal of elements. Next is the comparison between the stack and the queue. Stack uses the LIFO data organization and the queue uses the FIFO data organization. LIFO is last in, first out. FIFO is first in, first out. The operations used in stack are push and pop. The operations used in queue are NQ and DQ. And finally, the conclusion and summary highlights foundation of software design. Key learnings are understanding and implementing data structure is a fundamental skill for a computer scientist and software engineers. Next steps are further exploration, that is tree data structures, hashing algorithms, and more. Thank you.